Hello again, and welcome to problem solving session number 5. The focus of today's session is going to be present values. And these are, in my opinion, fairly straightforward questions. In other problem sets, we have reviewed present value questions that have an accounting impact and that have appeared on old exams. In this problem set, again, problem set number 5, there are problems to work through to get the general idea of how present values work. So they're a little bit easier than test questions because they don't usually include the accounting information, or they don't force you to analyze the accounting as much. So what we have done here is we have a couple of different questions we're going to go through, and this should go fairly quickly. Now, today's schedule, this session schedule, we're going to do 3 different questions from problem set number 5. And the first question is question number 3. We'll be doing part A and part C. And the basic idea is net present value, or what in the finance circle is called NPV. The second question is a situation where someone's taking out a loan. And then again, this should be important to you as individuals because you may take out loans for cars or mortgages for houses or things like that. So understanding how to do loans, which we have done in class and we have done even in other problem sets, is, I think, extremely important. And number 5 forces you, again, you're taking out a loan, but the question becomes, of the available opportunities, how do you make a choice? In other words, if you're going to finance something, what is better, and how do we do that? And the answer is it's all present value analysis. Here we go. Again, fairly simple questions. Question number 3. So you are asked to accept or reject these projects. So project A, and the key here is that we have a 12% required rate of return. That's very important to keep in mind. Project A, we have a cash outflow on January 1st of 1983, and we have a singular cash receipt of $100,000, far in excess of the cost. But note that it happens, let's see, that would be 8 years later. So we have an 8-year time lag between when we make the cash outflow and when we have the cash inflow. And the question becomes, does it make sense? Well, anytime I do a present value question, I draw a picture of the cash flows. So in this case, for problem number 3, the cash flow picture would look like this. We have a cash outflow right now, and that cash outflow is $45,000. And we have one cash inflow out in the future, and that cash inflow is $100,000. And so what we are doing is we are comparing the present value of the benefits to the present value of the cost. In this case, the present value of the benefits are $100,000 8 years from now, and the present value of that then would be the present value of $100,000 for 8 periods at our required rate of return, which is 12%. When we do that calculation, we find that the present value is $40,388. And then we compare the present value of the benefits to the present value of the cost, and we see that the benefits are less than the cost, hence we would not do this project. So for project A, we would not undertake that project. If our required rate of return was 12%. With a different required rate of return, we might be willing to take on that project, but not at a 12% rate of return. Okay, so much for Part A. Part B, and I'll just label this here. We'll go on to the next page. Part B. Bring our question back. We have a projected cash outlay of $45,000 again on January 1st, 1983, same as in A. But now we have a $100,000 receipt, but the receipt happens on each day, January 1st, 84 through 91. So we have 8 payments. Now, obviously, intuition should suggest to you that if we're getting $100,000 each year for 8 years, it's obvious that we are going to accept this project. So that is something you intuitively should guess up front. However, the question is, how do we model that? So let's make sure we understand how to model that, which is the whole point of why I'm doing this particular question. Because the answer is obvious, but the process is what we need to understand. So we draw a picture. Again, the current cash outlay is $45,000. And our decision criteria, the net present value decision criteria, is going to be the same. We compare the present value of the benefits to the present value of the cost. The present value of the cost is the $45,000 today. The present value of the benefits is an annuity stream in periods 1 through period 8, 84 through 91. And so the benefits then, this stream here, would be the present value of an annuity of $100,000 for 8 periods at, in this case, the required rate of return is 12%. And again, we knew that was going to be huge. It turns out the number is 496, almost 497,000, which, when compared to the $45,000 cost, obviously this is a big winner of a project. But again, the key thing in this particular project, in this particular example, is to understand how we model it. And we model it by simply drawing a picture and making sure that we know exactly what the cash flows are throughout the project. And then once we draw the picture, usually the present value calculations are fairly easy and fairly straightforward. So much for question number 3. Aren't these easy? Isn't present value fun? Back to our roadmap. Question number 4, A and B. This is a question of a loan. Here we go. Again, fairly easy, fairly straightforward questions. Number 4. Assume you take out a loan, so the present value or the amount of the loan is $50,000. And this loan is taken out on January 1st, 1983. Under the terms of the agreement, you must repay the loan in 8 annual equal installments at an annual interest rate of 9%. Again, everything compounded annually. Determine the amount of the annual payment you must make each year if A, the payments are made at the end of the year. So the first situation is where the payment's at the end of the year. The second one is when the payment is going to be made at the beginning of the year. Right? And you'll get different solutions here. Now, I will physically show you how I do it. You can do it a number of ways. I'm only going to do it one way right now. The notes describe how to do it through a different way, and the solutions do. But the first thing I do, as always, is I draw a picture. And the picture for Part A looks like this. We have a $50,000 cash inflow initially. And the question is, over time, and notice how I'm drawing this, in periods 1 through 8, at a 9% rate of return to the bank, or a 9% cost to us as the borrower, the question is, what is this annuity? And so the way we set this up, we know that $50,000 is equal to the present value of an annuity, and that's what we're trying to figure out, what's the annuity, for, or at 9% for 8 periods. Now, when you use a present value calculator to do that, and I'm going to show you very quickly how I do that on this calculator, and I've shown you in the past, but just for grins. Okay. First thing I'm going to do is I'm going to clear all of the registers that have anything to do with present values. Then I'm going to put in $50,000, which is our present value amount, but I'm going to change the sign because we need a sign convention. That's our present value amount. 9 is the interest rate, 8's the number of periods, and the question is what's the payment? And the payment's $9,034. So the answer to this question is $9,034 is the amount of the payment each period for 8 periods. And that's then would pay off a $50,000 loan. Now, the wrinkle here is beginning versus ending. So the key thing here is that there is a time elapse between when we got the cash and when we are making the first payment. Now, for the second example is a little bit different. This is 4A. Now we'll go to 4B. For 4B, again, same basic information, but it's made at the beginning of the year. And the picture's a little bit different. So you have to make sure when you draw the pictures make sense. You're getting $50,000 right now, and we recognize that, except for you have to recognize that you're making a payment right away. So the first payment's made on the same time as the loan that the amount of cash is discharged. So basically, they're cutting you a check for $50,000. That same day, you're cutting them a check for your first payment. Same day, same time, right? Kind of seems like a bad thing to do, but sometimes banks will do this. Now, my advice is to negotiate loans where your first payment's not till the next year, which is generally, or the next month or whatever, which is generally how these loans are done. So what's going on here is that what we have is we have some payment going off right here, and we really have a present value of only 7 periods because there are only 7 periods in the future because the first period payment is right now. So we do the same general thing, right? $50,000 is equal to the present value of an annuity, and the question is, what's that annuity? And I'll put a little A up here, a little flying A, for that's an annuity in advance. We usually do annuities in arrears at the end of the year. However, this is an annuity in advance. Now, on my problems and exams and in general, you will not see an annuity in advance. All right? But I wanted to do one just so you understood how to do it. And the way I will do it is going to be very simple. So this is an annuity in advance, and I'm going to do it in this case using 8 periods at the required 9%. And I'm going to do it in a way that's kind of cheating. I'm going to take my calculator, which we've already done, and I'm going to change the way the calculator does the annuity. And there's a little key right here, which of course you couldn't begin to read, that this is an annuity at the beginning or an annuity in advance. So I hit the function, I hit the G function, and make this an annuity at the beginning. And then using the same information, which is already plugged, and you can see right here on the display, it now says, that there says the beginning, so it's an annuity at the beginning. I now hit my payment, and this annuity at the beginning is $8,288. So $8,288 is the amount of the payment. Now that may seem like a bargain, because it was $9,000 before, it's $8,288 now. But remember, that's not really true. What's happening is they're giving you $50,000. You're giving back $8,288 immediately on that same day. Hence, you're really only getting a loan for $51,000 change, $51,700 or something, or $41,700 or something. So, you know, again, a little bit tricky, and you want to make sure that when you do your loan calculations, this was what? This was 4B. That you make sure you draw the picture correctly and then make sure you do the present values right. Now, my suggestion, another way to do present values, which is the way I will often do it in practice, is I will use a spreadsheet. I'll get a computer out. I use Excel. And so another way to do present value questions is to do it using Excel. And Excel will let you do it either at the beginning or the ending of the period. And that's one of the, again, things to keep track of there. So much for question number 4, our second question. Let's go back to our roadmap. Our roadmap is 3, again, relatively simple questions. We have done net present value. You now understand that. We've done loan calculations. Again, fairly straightforward stuff. Now, this is another loan situation, except for now we're trying to make a decision on how to finance or understand the parameters of how to analyze that kind of a decision. Number 5. So the situation is, I'm getting my cheat sheet ready on the side in case you're wondering what's going on. In this case, Harry Seymour is negotiating the sale of his boat. So Harry is selling the boat, and he's going to sell the boat to Herbie Rich. And they've agreed on a price of $40,000. Harry is willing to finance the purchase by accepting $15,000 up front and then $8,000 at the end of each of the next 4 years. That's one way. Now, assuming that Harry Seymour, the seller's appropriate rate of interest is 10% compounded annually, why is he willing to finance the sale under the terms specified above? So really what's going on is we can think of it in one of 2 ways. We can think of it in terms of the present value of the cash flow stream or in terms of the rate of return. And the way we're going to do it is we're going to analyze this in terms of the present value. And so what you would be comparing in item A, so from Harry Seymour's perspective, right, what we're really comparing here are 2 options. So this is 5A. One option is to get $40,000 in cash. That's one thing that could happen. The second thing that could happen is, in other words, Harry could demand the cash up front, or he could be willing to finance this thing to a willing buyer. And now the question is, why would he be willing to finance? And so option 2 is to finance. And so in order to determine which one is better, what do we have to do? We have to take the present value of the benefits of financing, compare them to the present value of getting all the cash up front, and see which is better. So if we look at the present value of the financing option, the present value is he has agreed to get $15,000 up front and $8,000 at the end of each of the next 4 years. So what we have is a situation where he's getting $15,000 up front, and he's getting $8,000 each year for 4 years, 1 through 4. So the way to figure out the present value of the financing option is to take the present value of the present value of his annuity of the $8,000 for 4 periods at his required rate of return, which is 10%, which is his investment opportunity rate of return. That present value is equal to $25,358. Add that to the $15,000 he gets up front, and the total amount, the present value of the financing option, would be $40,358. So now we compare the option of financing, which is a present value of $40,358, to the option of getting cash up front, which is $40,000. Hence, we can see the present value of the benefits from financing are larger than the present value of getting cash up front. And that is why this guy, Harry, would be willing to finance this particular project to a willing buyer. Okay, 5B. Assume that Herbie Rich's appropriate rate of interest is 12%. Now, what does that mean? What that means is that Herbie Rich can invest at 12%, whereas Harry Seymour, can only invest at a 10% rate of return. Hence, Herbie's opportunity cost is relatively higher. Now, would Herbie Rich, would he prefer to finance the boat under the terms outlined, or would he be willing to pay $40,000 immediately? Now remember, we already calculated that if Herbie Rich's opportunity costs were 10% per year, he'd rather pay up front, because the present value of financing would be larger than the present value of paying up front at a 10% rate of return. However, Herbie has a better opportunity for investments, hence he uses 12%. So now we do the same kind of calculation under a 12% scenario. So we look at the same picture. So from Herbie's perspective, this is 5B. From Herbie's perspective, does he want to pay, his options are to pay $40,000 up front or to finance? And the way to calculate the difference, in order to determine this, is to take the present value of the financing option. So the present value of the financing option is going to be the $15,000 plus the present value of the payment, an annuity of $8,000, for 4 periods at Herbie's opportunity cost, which is 12%. Now, when we add all that up, we get that Herbie's opportunity cost is $39,298. Hence, the opportunity cost of financing is less than the opportunity cost of paying $40,000 in cash up front. In other words, it's cheaper to finance at a present value of $39,298 than it is to pay cash. Hence, Herbie would prefer to have, then Herbie would prefer to have Harry finance it, and then Herbie would be willing to borrow. Okay. Now, C. So the answer to B is what? Herbie would prefer to finance it. We go back to item number C, which we've kind of already addressed. If Herbie Rich's appropriate interest rate were 10%, would he prefer to finance or would he prefer to pay immediately? And remember, the first scenario, we looked at the present value at 10%, and we found that the present value at 10% was $40,000 for financing. So if the opportunity rate to Herbie Rich were 10%, the opportunity cost of financing would be $40,000. The opportunity cost of paying cash, the opportunity cost of finance is $40,358. The opportunity cost of paying cash is the $40,000 in isolation. Hence, if Herbie's opportunity rate of return, if it were 10%, he would prefer to pay cash up front rather than finance. So much for problem set number 5. I hope these problem sets are a help. Again, the key, many times the decisions are obvious, but the key is to understand the process of analysis. And for net present value, which is very, very important for both managerial and for financial accounting, but the net present value criteria is very simple. You compare the present value of the benefits to the present value of the cost. If the benefits are greater than the cost at the required rate of return, then we will do the project. If the benefits are less than the cost, then we will not do the project. Again, all in present value terms. Well, I hope these sessions have been helpful. Go back to the roadmap very quickly. What did we do in this session? Net present values, a loan in terms of calculating, and the alternative financing. In other words, the economics of making decisions using present values, which I think is very important. It's not important for accounting, but it's very important for you as decision makers to understand how to use present values to help make decisions. Thank you very much.